Okay, today's class is on sliding window. We will have a short class since because of our meeting. Okay, sliding window. So the first thing that we do in sliding window is the question. This is the standard question, which is given an array 3, 8, 4, 0. The question is what is the sub-array which gives maximum sum? It's contiguous subarray. So when you say subarray, it's usually contiguous. Okay, so US isn't contiguous. Uh, but so in this case, which one is the answer? So in fact, return sum. Return the sum. You don't have to return the subarray. So which will be the subarray in this case, which will give maximum? And also I'm going to give you k is equal to 4. That's the window size. So the question is given k is equal to 4 and a is equal to this array here. Find the contiguous subarray of size 4, which will give you the highest value. Where is my... Oh, so you didn't see any of this yet, huh?
No.
Is this the first time? Okay, perfect. Okay, better late than never. Okay, sorry. This is the question, which is you're given an array like this. A is equal to 5, 3, 1, 2, 8, 4, 0, and the value of k is equal to 4, which is the window size, which is the maximum contiguous subarray, which is in this case, I'll give you an example of a maximum subarray. In this case is new color, new color, new color. Okay, so this is your starting maximum subarray window, right? 1, 2, 3, 4, window of size 4. So if you look at the sum of this, it's 5 plus 3, 8, 9, 2, 11. And the next subarray is this one, which is 8 plus 2, 10, 11, 14. Third subarray is here. So this is 8 to 10, 14, 15. And that probably is the biggest subarray because the only one left is this, which is 8 plus 2 plus 14. Okay. So this guy here is what our answer is. We're looking for is this subarray 1, 2, 8, 4, 0. Now, what is the brute force way of doing this? We always start with the basic brute force way. Okay, just to remind you, the steps that we have been writing is understand / paraphrase. Paraphrase. For logic is what we are doing now. For logic, of course, pen and paper or iPad and pencil. And then we do a edge / null. We do a dry run. Then we also, then only we move it to the code editor. So for logic in the earlier, so far we have seen for logic in recursion, and this is probably the first time we are not using recursion since the class began. So remember, the reason we were using recursion was that is the equivalent of a brute force, right? So we started with the recursion, and eventually we saw that recursion is a bad idea. So let's start with, let's do more improvements. In case of dynamic programming, we saw we can do a lot of improvements starting from O of n squared. We went, I think, all the way to n for the number of steps problem. But anyway, the idea is still the same, where we start with the brute force and we try to improve it. So if you're given this question, a is equal to 5, 3, 1, 2, 8, 4, 0, and k is equal to 4, the window size, how will you find the maximum contiguous subarray? Okay, what is the brute force way of doing this?
I think we will have like 2 for loops, and the inner for loop will go from the current index to current index plus 4.
Yeah, okay, that's perfect. Yeah. So, so the way we can row it is like you said, 2 for loops. We'll start with the first for loop. in, let's say, s is equal to 0. So I'm going to call s for start and e for end. S here. So I'm starting s and e is both here. Let me actually rewrite this somewhere here so that we don't have to keep going up and down. A is equal to 5, 3, 1, 2, 8, 4, 0. Okay, so I'm declaring two pointers, s is equal to 0 as for start, and another for loop inside for another pointer, s is equal to 0. So this one can go from, let's say, if I tell you we need length, right? So we're going to say int n is equal to a dot length. And if you're trying to make a window, like for example, this is your starting window and s is here and e will be here, how far can s go? I mean, sure, you can start with s less than n, but do you really need to go all the way to n? Because your maximum you have to go is here, right? You should stop here because if the window size is 4, s doesn't have to go anything beyond this number 2 here. So if you're looking at indices, if you want to put indices, you basically 0. I think this awesome color 0, 1, 2, 3, 4, 5, 6. So in this case, you really just have to go until index 3. So index 3 in this case is if let's say a is equal to length, a dot length is 7 elements here, right? You can actually say you have to go only till 4 or n less than 4. So we can just do n minus k, which in this case is 7 minus 4, that's equal to 3. So let's say 0, 1, maybe that's not equal to, right? Because n is 7, so anyway, n is 7, 4 is the window size, 7 minus 4 is 3, so we might have to do that's not equal to. And s goes all the way to this guy here too. Okay, so this is the first for loop. And what we'll do is we'll create a sum variable. So local sum, it's called int local sum equals 0. And we create another variable start. So this s is for start, that's called end. It starts at same place where s is initially. And we will that you can go all the way till s plus k always, because your end will be has to be less than 4 elements from start. E plus plus. Okay. So our goal here is local sum plus equals a of e. So all we are doing is take this window, starts from 5. S is at, and when you start S is here at 0, then we come in, E starts here. E was initially here next to S, and we do E plus plus, E plus plus, E plus plus until we reach S plus K. So we hit 4, right? So it will be 0 plus 4 is 4, so we should stop at 3. And we are summing it all up. And then we have to want to check if this my local sum is bigger than a global sum. So you need to define int global sum, very clean writing, 0. Okay, in global sum, so what we'll do is local sum, if local sum is greater than global sum, we replace global sum equals local sum. Okay, so this is your basic brute force method of doing this. Like 2 for loops, and you have literally have a sliding window. But what is the time complexity of this?
A into n.
Sorry, what?
K into n.
K times n,
A.
right? So
Yeah.
n times k, which is where k is the window size and n is the total number of elements, right? Now, if somebody says my window size is n minus 1, so this can asymptotically go all the way up to n squared. Right? So what will be a better way? So let's call it ground 0, or remember I have solution 0. This is the format we are using for dynamic programming. So now we start optimizing it. Solution one. What is an optimization you can think for this? Better than order of n squared.
A sliding window.
Yeah, but this is a sliding window, right? What you're looking at is sliding window. So this window is of
Basically,
size.
mm,
Currently,
add
this
one
window
for
is of
loop.
size 4. Okay, so this is a window of size 4. So we are already having a sliding window, which we are literally sliding. So, okay, so you're saying you have one for loop. I need to work on my colors. Okay. I have one for loop. Okay, and what is the idea for one for loop? It's order of n. We were literally sliding this window over here. Okay, so if it's one for loop, how can we improve it? How do you do that?
Um, Basically, we have like two pointers, start like cut 2 pointers, and we keep summing it up as in when we reach forward. But when we encounter the index 4, when we are at the fourth value, we check, we update our global sum or current sum. And when we move forward, we decrement the starting index value and we add the ending index value.
Perfect. Oh, I'm not checking the chat window. I just saw chat window where you say light green color is too light. You're assuming I know what light green color means. The truth is I'm colorblind. So for me, all this looks like bright stuff, no names, which is why you will always see me mixing up colors. But so what you said is right. It's okay. So what essentially what you are saying is if you look at this before people watching this video, if you really think about this, let's rewrite this array again. A is equal to 5, 3, 1, 2, 8, 4, 0. So now what we are doing is we are taking, let's see, new color. We were taking a window here and trying to slide it across. But instead, so every time we were getting the sum of this window, but the truth is, you really don't care about the sum all the time. You only care about it once. Say, let's say you start with 5 plus 3, 8 plus 1, 9 plus 2, 11. When you slide the window one ahead, what you essentially are doing is you're removing 5 and adding 8, right? So in this new window, which is 3, 1, 2, 8, if you remember, the sum was 8 plus 2, 10 plus 1, 11 plus 3, 14. But 14 is actually nothing but 11 minus 5 plus 8, right? Is it 19 minus 5? Yes. Okay, 19 minus 5 is 14. So the core idea is, in that case, we just save this inner sum loop that we don't have to do that again. So this is like a very common question they ask. It's a very simple question, but it's an interesting trick. Yeah, vaguely remotely interesting trick. But this is like the devil, you need to know this guy. So, okay, so let's try coding this up again. Two hands, nope. Right, give me a second, I'm making it wrong setting. Apple pencil. People only draw with Apple pencils, yes. Why is it not? So let's see. So same thing, let's start with int a global sum, right? So global sum equal, I start at 0, but keep in mind that it might not be always 0. There might be cases, especially when you write this, when I say, remember when we are writing pen and paper, and the reason I make you write int global sum is equal to 0 in the Java format is, now you just had a discussion with yourself. Oh, wait, can global sum be 0? What if, can you think of a place where global sum might not be 0? Or if I start with global sum, it'll fail. You know why? global sum is equal to 0.
Can you
No.
repeat the question?
So remember in the last case, we started with global sum is equal to 0, and we were comparing the local sum, the inside sum of the window, and we were replacing the global sum with the local sum here. If we find the local sum is greater than global sum, it'll work in this particular example of an array, but this is a
Yeah,
time your
it will
brain
fail
should have
when
thought.
we have negative integers in the array.
Perfect, perfect. So for example, if you had an array like -1, -5, -3, sum of all these three, let's say, sake of argument k is equal to 4, we sum this all up, put the -11, is it greater than 0? No, so you will never replace this. So this is a question at this point is when you ask the interviewer, if you haven't asked yet, that can it contain negative integers? If he says yes, replace this with int underscore min, or if he says it will be only positive integers, leave it at 0. But this is the beauty of writing it down step by step yourself. So what is next? You said one for loop, right? So which for loop are you looking for? Start or end?
Um, Not sure.
Okay, so what is the very first thing I said? We need 11. So we need somewhere to start, right? What is 11 here?
Sum of first four values.
Yeah, so we need somewhere to start. So what we'll do is we'll try also call it int local sum 0. So let's sum it all up for the first thing, right? Int I is equal to 0, I less than k, plus plus. We are just going to do local sum plus equals a of I. Right? So all we are trying to do is by the time the for loop ends, this value will be, in our case, 11. That's probably faster. So once we have this value, our local sum is 11, now we can actually start our first original, the for loop you are mentioning, because this one is just an order of k operation. So that's something we can live with. But let's say, so if I say, okay, so let's do the same thing, int start is equal to 0, int end is equal to k. And I say, I just need only one pointer now because I really don't care about the other one. Remember, we are trying to move one thing at a time. So S is here initially and E is here. But what we really care about is when we move, E moves here, E to 8, S moves to 3, but we have to remove A of S and add A of E. So how do we write that? So I'm not even filling up the while loop yet, right? We need to get to the core logic as fast as possible. Our core logic is local sum is equal to local sum minus A of S plus A of E. Exactly, have 2 more minutes, very smart. And S plus plus, E plus plus. Next class onwards, we'll probably switch to Python because I think our brains are already automatically checking. Okay, so what is the condition we are looking for here?
Local sum is greater than max
Yeah,
global.
local sum greater than global sum. Global sum equals local sum. I should really use uppercase to make it at least do some justice to my handwriting. Terrible. Okay, so that's it basically, right? We are done. We just need one for loop, and all we're doing is removing the first element, adding the next, remove the previous element, add the next element, and till when should we keep going? So let's go back. What did we do the for loop last time? The for loop went all the way from, oh, the outer for loop was going till n minus k. and the inner for loop was doing s plus k, so we don't have the inner for loop again. So all you need to do is go, let's even do like just the E. The E is the end pointer. You can call this even S, but doesn't matter. E, I'm going to say E less than A dot length. Does that look okay? And the truth is we're done. We just now converted a solution for order of n. So earlier it was order of n squared, almost asymptotically, and at least n dot k, but now we have a solution order of n. These are simple tricks, but this will be useful in a lot of other problems. Okay, let's stop here because we have to go to the other class. Next class will be Wednesday, 4 o'clock, and we are going to have Monday, Wednesday, 4 p.m.